Hi, Piyush. Welcome back to the channel. Good to see you again.
Likewise, man. Good to be back on your channel or podcast, whatever you call it now.
NextGenIntra.io.
There you go.
Yeah, first, congratulations on the announcement. I have a couple of questions around, why SiTime is entering this space and what differentiates your offering. But before we jump into that, could you remind our audience what is a resonator?
Sure. So I'll get to it in about a minute, but let me just give a brief background of SiTime because it's contextual. It helps with the story. So for the last 2 decades or so, SiTime has been focused on delivering precision timing solutions to the electronics industry. Precision timing is different than all timing, and precision timing serves the needs of modern electronics, which is becoming faster, which is becoming more dense, and which is always connected and is being deployed in uncontrolled environments. It's not in pristine offices anymore. And so in all of these environments, there are environmental stresses that come into play. Shock, vibration, extreme temperatures, rapid temperature changes, EMI noise, power supply noise, all these things come into play. And our claim to fame is that we are more resilient to all of these than the other legacy industry, the legacy timing industry, and therefore we allow the electronics devices to give higher performance. Now, in timing solutions, there's a bunch of different types of devices. For the last 2 decades, we've been focused on oscillators and clocks. An oscillator is an active device. It basically puts out a clock signal, a square wave in most cases. And then a clock device is basically could be one of 4 different types, a clock generator, a buffer, a network synchronizer, a jitter cleaner, but it puts out multiple clocks. At the heart of both of these devices is something called a resonator. A resonator is a mechanical device. It vibrates at a resonant frequency. And that resonant frequency, the mechanical energy of that is converted to electrical energy using a circuit called an oscillator circuit. All our products, oscillators and clocks, have shift with resonators in them. But now what we're doing is we're offering a standalone resonator, one that can interface with any semiconductor device, like an ASSP, like a microcontroller, like an SoC, and that device will generate the clocks for its internal circuitry. So in that sense, if you look at the markets, the oscillator market is about 4 billion in size. The clock market is about 3 billion in size. The resonator market is about 4 billion in size too. And so by offering a resonator now, we not only have oscillators and clocks and software, but we also have resonators. So that makes us a complete precision timing solution provider.
I see. And so the conventional approach for a resonator, and correct me here, is quartz, right? You're applying a voltage to a quartz and it's resonating at the frequency that you want. What is first off, is that correct? And then secondly, what's your approach?
That's correct. And what they do is they use quartz crystal technology to build their resonators. And that technology is very mechanically intensive. There's a lot of grinding, plating, deposition, all that stuff that happens in building a resonator with the correct resonant frequency. In our case, we use MEMS technology. And so literally, if you look at our devices, they're built on an 8-inch wafer. There's anywhere from 80 to 100,000 devices on there. Each one of these is vacuum sealed. And so it's like a semiconductor die. And that semiconductor die, a resonator, we put it inside our packages for an oscillator circuit with an analog circuit to create an oscillator. We expect that at some point, our customers will also do the same. They'll take our resonator die, put it inside a package with, for example, their microcontroller, 32-bit microcontroller, or a BLE SoC, or whatever they might be offering, so that they can create a more integrated solution for the customer and eliminate timing from the board completely and have it be integrated inside the package. That's one of the use models for our Titan device. And another, of course, is the traditional classic one, where you lay it side by side with the device so that it provides a clock to the device.
I see. And so walk us through some of the technical differentiators of using a MEMS, and what does that ultimately end up meaning for the applications?
Great point. So one of the biggest value propositions, as I talked about, is the ability to integrate a functionality that is adjacent on the board into the semiconductor device. And that's the name of the semiconductor game. We've been playing this game for the last 40, 50 years. We take adjacent functionality and incorporate it into the device. I mean, a clock device came into existence exactly in that manner. People looked at multiple resonators or oscillators on a board and they said, hey, we can use PLLs to integrate this and create a single device. And that's what they did. So same concept here. We're doing that. We're basically integrating that. So that's one benefit. And it solves a whole bunch of problems for customers. Customers don't have to worry about which resonator to buy. They don't have to worry about how to place it compared to the SoC or microcontroller. They don't have to worry about any signals coupling in onto the traces because this is a clock signal. It has to be clean. So they don't have to worry about that. So the semiconductor companies who integrate this are adding value and delivering value to the customer. And for that reason, they could potentially charge for it too. Now, what are some of the benefits, other benefits? If you were to lay it down side by side on a board, then even in that scenario, our occupied area for the resonator on the PCB is 4x to 7x smaller than a comparable quartz resonator. And our die is 0.5, or sorry, our package is 0.5 by 0.5 millimeters. And the quartz devices are anywhere from 1.0 by 0.8 millimeters to higher. So what this does is it allows space-constrained applications, things like IoT devices, things like anything that is space-constrained and uses wireless connectivity. They allow those devices to save even more space so that they can add more features and functions to it. Whether it's longer battery life, whether it's something else, they can add it to it. So that's another benefit. And then because of our MEMS technology, resilience is always a benefit. Reliability is always a benefit. We are like 30 to 50 times better than quartz devices on that. And then there's some additional benefits like faster startup time to save system power and things like that. So there's a bunch of these kind of benefits that we offer.
Okay, great. One final question before we wrap up, and it's what's next? How do you bring this to market?
Yeah, so we obviously we will work with OEM customers too, but in this case we're also working with chip companies and the chip companies who create reference designs. We work with them. The chip companies who are looking to provide a more complete solution by integrating the resonator, we'll work with them too. So microcontrollers, BLE SoCs, and we are actually in a bunch of different BLE SoC reference designs already. We're not allowed to name them because they haven't given us permission, but we are on there, so the customers are going to see it. So that's one model. The model of working directly with OEMs is always there. In terms of roadmap, we have to look at frequency coverage. How do we expand our coverage? So today we are offering a 32 megahertz device. By the end of this year, we will be sampling 4 other frequencies, 38.4, 40, 48, and 76.8, which are very popular in this domain. And then over time, we're going to expand to more and more frequencies. We'll go into wired communications potentially. We'll go into higher frequencies potentially. There's a bunch of different options on the table. And depending on how we align with our customers' roadmap, those things will be developed and put out there. By 2028, we are expecting that we'll cover about $1 billion SAM, serviceable market, with all the stuff that we have today as well as in the roadmap. And the whole market is 4 billion and growing. So that's still a smaller percentage of the whole market for resonators. But we are going in primarily after the places where we can add value, whether it's size, whether it's performance, whether it's resilience, whether it's reliability, a bunch of different things. That's where we are focused.
All right. Huge potential. Always good to talk to you, Piyush. Keep at it.
Likewise, man. Thank you.